Another group of integration involves trigonometric functions. Check how this is done here in integral calculus. Based on the previously identified derivatives, a list of trigonometric integrals are noted, starting with the integral of sine u du, which is negative cosine of u plus c. Next is the integral of cosine of u du, and that is sine of u plus c. There is also the integral of secant squared u du, which is tangent of u plus c. Then the integral of the square of cosecant u du, which is negative cotangent u plus c. Another is the integral of secant u tangent u du, which is secant of u plus c. Then the integral of cosecant u cotangent u du becomes negative cosecant u plus c. With the 6 basic integrals, there is also the integral of sine u over the square of cosine u du, which is secant u plus c. And flipping the trigonometric functions, making the integral of cosine of u over sine squared of u du, that becomes negative cosecant u plus c. There is the integral of tangent u du, which is ln of secant u, and inversely, the integral of cotangent u du is equal to ln of sine u plus c. The first example is finding the antiderivative of cosine 4y dy. From the list, there is the integral of cosine u, that becomes sine of u plus c. So take a closer look at the integral. We can note that u is 4y and its derivative is 4 dy. Having a derivative of 4 dy requires a little adjustment of the function. That is, 4 is multiplied to the derivative and 1/4 is placed right before the integral. So using trigonometric integration, the integral of cosine 4y dy is equal to 1/4 of sine 4y plus c. Another example involves the integral of cosine x raised to 4 multiplied by sine of x dx. Due to the exponent 4, we take u as cosine of x, and its du is negative sine of x times dx, and n is 4. Go back again to the derivative requiring negative sine x dx, but the function is just sine of x dx. So adjust it by multiplying negative 1 and doing the same before the integrand. Now that everything has been prepared, proceed to the integration using simple power formula, which makes negative cosine of x raised to 4 plus 1 over 4 plus 1 plus c. Simplify the function to have the integrand as negative cosine x raised to 5 over 5 plus c. Example 3 involves the integral of cosine x dx over sine of x raised to 4. We place the denominator on top to have the integral of sine x raised to negative 4 multiplied by cosine x times dx. Check the components of the function and take u as sine of x. Du is then cosine of x dx. Then n is negative 4. Du is exactly what is placed in the function, so no need to multiply anything. So proceed to integration using simple power formula. That is, sine of x raised to negative 4 plus 1 over negative 4 plus 1 plus c. Further simplify the exponent and denominator into sine of x raised to negative 3 over negative 3 plus c. Then, to avoid having a negative exponent, take the reciprocal of the term, making the integral of 1 over negative 3 sine cube of x plus c. The next example is the integral of the quantity 4 minus 3 sine of 2 beta raised to 4 times cosine of 2 beta d beta. Check the components starting with u as the quantity of 4 minus 3 sine of 2 beta. The derivative of u becomes 0 minus 3 cosine of 2 beta times 2, which is simplified as negative 6 cosine of 2 beta d beta, and also n is 4. So having a constant in the derivative, let's adjust the function by multiplying negative 6 to cosine 2 beta d beta, and also to have negative 1/6 before the integrand, to make the whole function easily integratable. Now, use simple power formula to have negative 1/6 times the quantity of 4 minus 3 sine of 2 beta raised to 4 plus 1 over 4 plus 1 plus c. Simplify the addends and have the final antiderivative as negative 1/30th of the quantity 4 minus 3 sine of 2 beta raised to 5 plus c. Example 5 requires the antiderivative of the quantity 3 plus 7 sine of w over cosine squared of w dw. First off, make two simpler terms according to the numerator. So there are the integral of 3 dw over cosine squared of w plus 7 with the integral of sine w dw over the square of cosine w. For the first term, employ the basic identity that the reciprocal of cosine w is secant w. For the second term, as it has a denominator, flip it up to have a single line function, then analyze its components where u is cosine of w, du is sine of w dw, and n is negative 2. With the derivative exactly the same as the one from the function is readily integratable using simple power formula. So the first term is integrated as 3 times tangent of w plus 7 times cosine of w raised to negative 2 plus 1 over negative 2 plus 1 and add c. Simplify the exponent and numerator to get 3 tangent of w minus 7 cosine of w raised to negative 1 plus c. Take down the term with the negative exponent and have 3 tangent of w minus 7 over cosine of w plus c.